Hi guys, I welcome you to my YouTube channel, Learn Physics with IBM. Remember to subscribe, share the documents in the video description, download the videos, watch them at your convenience. It's better you print out the multiple choice questions and you practice on the hard copies rather than just watching videos. If you have a tablet, you can do it on the tablet so that you have a saved copy just for reference, maybe if you're preparing for exams. If you're a teacher, you can just download the multiple choice questions and print, give your students, and send them to my YouTube channel to follow the videos, practice, and I assure you they will get a lot of confidence. So without wasting time, I would like to take you to part 11 of solved past paper questions, force, density, and pressure. So in part 10, we stopped on page 90, and in part 11, I want us to start from this question here. So let's get started. A rigid L-shaped lever arm is pivoted at point P. Three forces act on the lever arm as shown in the diagram. What is the magnitude of the resultant moment of these forces about point P? Magnitude of the resultant moment about point P. So let's check. About point P, the 5 Newton force is causing an anticlockwise moment. Its perpendicular distance is going to be this distance here, which I think is going to be this distance is going to be the whole distance here, which is 4 minus 2, which is going to be equal to 2 meters. Then this force here is causing an anticlockwise moment in that direction, whose perpendicular distance is going to be 2 meters. And this force here is causing a clockwise moment, and its perpendicular distance is going to be this distance here, which is the same as 3 meters. So it's now easy to find the resultant moment. So we shall simply say we shall find the clockwise moment. Clockwise moments, we have 15 newtons times the perpendicular distance, which is 3. And this gives us, I think this is 45 Newton meters. Then the anti-clockwise moments is going to, we are going to have 5. Perpendicular distance is it 1 or 2? Let me check again. 3 plus 3 plus 3 plus 1, that is 4 minus, so that is 2. So this is going to be times 2. 5 times 2 plus that is 5 plus 2 times 5 times 2 plus, this is also causing anticlockwise moment, so that is going to be 10, and the perpendicular distance here is 2. So this gives us 5, I think this gives us 30 Newton meters. So this is 30 Newton meters. So what is the resultant moment? We see that the clockwise moment is bigger than the anticlockwise moment. So the resultant, I've just used R for resultant, that is 45 minus 30. This is going to be 15 Newton meters clockwise. So the answer is going to be A. Two parallel forces, each of magnitude F, act on a body as shown in the diagram. What is the magnitude of the torque on the body produced by these forces? Remember, torque is the product of one of the forces and the perpendicular distance between the two forces, and the perpendicular distance between the two forces is actually S. So it means the torque of this couple is going to simply be F times S. So the answer is automatically Fs, one of the forces and the perpendicular distance between the two forces. A street lamp is fixed to a wall and a metal rod and a cable by a metal rod and a cable. Which vector triangle represents the forces acting at point P? So This lamp is fixed and is in equilibrium, so the forces must be forming a closed triangle. There is tension in that direction, there is weight which should be vertically downwards, and there is a normal reaction force which comes from the wall. So the normal reaction, there should be force in the horizontal pointing that direction, there should be force in the vertical pointing downwards, and there should be tension in the cable. And these three, they should form a closed triangle. So let's first check by eliminating those which do not form a closed triangle. So A is forming a closed triangle. B is forming, this one is automatically not correct because this is not a closed triangle. Remember, for equilibrium, we must have a closed triangle. So this one, if I move like this, the other one is the other way around. So this is automatically out. Then we can check C. C, if I move like this one is the other way around. So this is automatically out. Then D and A, they are forming closed triangles. But remember, the weight should be vertically downwards. This one is showing a vertical force upwards. This one is showing the weight is downwards. That is correct. So this is wrong weight. Then the normal reaction should be to the right hand side. This is showing it to the left. And then the tension should be in this direction. So the answer is automatically going to be D. If you look at the diagram, the weight is vertically downwards. The reaction from the wall is to the right, and the tension points in that direction. So the answer is going to be D. The Mariana Trench in the Pacific Ocean has a depth of 10 kilometers, assuming that seawater is incompressible and has density of 10-20 kilograms per meters cubed. What would be the approximate pressure at that depth? Okay, this is direct. We have done it so far. Pressure is equal to density times G times H. So this density is 10, 20 times G, which is 9.81 times 10,000 meters. So we just check our calculator. 10, 20 times 9.81 times 10,000. So this is 368, 10 power 8. So the answer is going to be D. This is approximately 10 power 8. So the answer is D. The graph shows how force depends on extension for a certain spring. So this is supposed to be in deformation of solids. What is the energy stored in the spring when the extension is 30 millimeters? But we shall still solve this because it is easy. So energy stored is equal to a half Fx, if you remember deformation of solids. So this is going to be a half times F. F for 30 millimeters, F is, okay, for 30 millimeters, okay, I will just check with the 6. So this is, if I take 30 and 6, so this is a half times 6 times 30 times 10 power minus 3. So this is giving me 0.09 joules. Remember, I took 30, but it's supposed to be slightly above 6. 30 corresponds to a force which is slightly above 6. That means the energy should actually be greater, but should be close to 0.09 joules. So the energy should be close to 0.09 joules. This may not be exactly 0.09, but close to 0.09 joules. So this is wrong, this is wrong, this is wrong. So it means the answer is going to be A. Because I took 6 instead of 6 point something, you could take this as 6 point something or 6, because from 6 you go to 8. So this space must be divided by 2 must be divided by that space. So to get equal divisions, this could be approximately 6.2 maybe. So I used just 6 to get 0.09. So I know the energy must be close to 0.09. Actually, it should be greater than 0.09. Close to 0.09 and greater than 0.09. That's why the smallest here is 0.095. So the answer is automatically going to be A. The diagram shows a rope bridge that a student makes on an adventure training course. The student has a weight W, which formula gives the tension T in the rope. So let's just do a vertical line for the weight of the student. This is W. And for there's tension here, there's tension here. We are going to resolve the tensions vertically upwards. Taking T vertically upwards will be T sine of theta, and this side it will also be T sine of theta. So these two should add up to give us which formula gives the tension in the rope. So these two should add up to give us W. So we have that T twice T sine of theta should equal to the weight. In the horizontal, if we resolve horizontally, we have that T. In the horizontal, we have that T cos theta is equal to T cos. So this one cancels out in the horizontal, there is equilibrium. So when I make T the subject here, T is going to be W over 2 sine theta. So the question is, which formula gives tension in the rope? So T is going to be W over 2 sine theta, which makes the answer to be B. A spanner is used to tighten a nut as shown. A force F is applied at right angles to the spanner at a distance of 0.25 meters from the center of the nut. When the nut is fully tightened, the applied force is 200 newtons. What is the resistive torque in an anti-clockwise direction, preventing further tightening? So it means if it is fully tightened, what is the clockwise torque to begin with? So clockwise torque is going to be equal to the force, which is 200 newtons, times the perpendicular distance, which is 0.25. When it is fully tightened, so this is, I think this is 50 Newton meters. So it means the anti-clockwise torque should be equal to the clockwise. The anti-clockwise should be equal to the clockwise, so that if it is not to be fully for it not to be tightened any further, the anti-clockwise moment is going to be equal to the clockwise moment. So the answer is going to be automatically 50. So the answer is C. The diagrams show a metal cube suspended from a spring balance before and during immersion in water. So before we see the position, and after we see that the position is now bigger. So it means the upthrust has increased. A reduction in the balance reading occurs as a consequence of the immersion. Which statement is correct? The balance reading will be further reduced if the cube is lowered further into the water. No, the balance reading will remain constant if it is lowered further, because the upthrust remains constant. The balance reading during immersion corresponds to the upthrust of the water on the cube, not at all. The balance reading is going to be the weight minus the upthrust. The balance reading is the weight minus the upthrust. The force acting on the vertical sides of the cube contribute to the change in the balance on the vertical side. That is pressure, the force on the vertical side, that is not true. Does not contribute to the change in the balance reading. The gravitational pull on the cube is unchanged by the immersion. I think this is a very correct statement. The gravitational pull is the weight. The weight remains constant, but the reading is equal to the weight minus the upthrust. When the cube is fully immersed, the upthrust is constant, and the weight, of course, is always constant in the same medium. I mean, due to gravity is the same and the mass is the same. So the reading is weight minus upthrust. When the object is fully in water, the reading remains constant. Not until we remove it from the water that the reading now reduces. So the answer is D. The gravitational pull on the cube is unchanged by the immersion, that is the weight, because the weight is depending on the mass times G. G is not changing, the mass of the object is not changing. Therefore, the weight remains the same. The pressure at sea level is approximately 100,000 pascals and the density of seawater is 1030 kilograms per meters cubed. What is the approximate pressure 80 meters below the surface? Okay, this is IGCS, I think. This is an IGCS equation. So pressure or difference in pressure is equal to density times G times the difference in height or depth. So they have given us the pressure at sea level and they want us to find the approximate pressure at 80 meters. Of course, the pressure at 80 meters is going to be greater than the pressure at sea level because of the liquid. So we shall simply say that P minus 100,000 P minus 100,000 should be equal to the density, which is 1030 times G, which is 9.81 times the change in height, which is 80 meters. So I'll just press my calculator. 1030 times 9.81 times 80. Then I'll add plus 100,000. So this is giving me 908 or approximately 900,000. So P is approximately 900,000 pascals. So the answer is going to be D. So it will be a higher pressure if we are 800 meters below the surface of the sea. Two wires P and Q are made from the same material. Wire P is initially twice the diameter and twice the length of wire Q. The same force applied to each wire causes the wires to extend elastically. What is the ratio of the extension in P to that in Q? Yeah, we have done this equation, but of course this is under force density and deformation of solids, but we shall still answer it. We know that Young modulus is stress over strain. Stress is force over area, and strain is extension of original length. So when we multiply, we get the reciprocal. Also remember that the area is pi r squared, which is pi d squared divided by 4. So it means the Young modulus is going to be equal to 4f L divided by pi d squared times the extension. So let's now come up with the two equations. Of course, since it is they're made from the same material, the Young modulus is the same, so E is the same. So this I will just equate the equations. For Q, we shall have 4f, the length of, for P, for F. Now let me start with the Q because P is initially twice the diameter and twice the length of Q. So for Q, it is going to be 4fL over pi d squared times, let its extension be E. And then for P, it is going to be 4. Because the force is the same, I'll write F. Then the length is twice that of Q, so this will be twice L divided by pi. The diameter is twice, so this is going to be 2d but squared times the extension. I'll call it y. So 4 cancels, F cancels, L cancels, pi cancels. So I have 1 over d squared times E is equal to 2 over 4d squared times y. D squared cancels out. So I cross multiply. 4y is equal to twice E. So it means y is equal to a half of E. So the question is, what is the ratio of the extension in P to the extension in Q? Automatically that is going to be a half because in y is a half E and in Q it is E. So the ratio is a half. So the ratio is going to be a half E over E. which is a half. The diagram shows for forces applied to a circular object. Which of the following describes the resultant force and resultant torque? Resultant force, this side, it is going to be 40 newtons. In the vertical, it is 0. So the resultant force is not 0 because it is 40 newtons to the right. So it is non-zero. We ignore A and B. Then torque. This causes a clockwise moment, which is cancelled with this one, because this is anti-clockwise. So these ones are cancelled out. But 30 newtons causes clockwise. This 30 causes clockwise. The resultant is a clockwise moment. So it is not 0. So this is also out. So the answer is going to be D. A balloon is acted upon by 3 forces: weight, upthrust, and sideways force due to the wind, as shown. What is the vertical component of the resultant force on the balloon? Vertical component of the resultant force on the balloon. So, first of all, in the vertical, we have 10,000 minus 9,000, which gives us 1,000 newtons. The question is, what is the vertical component of the resultant force on the balloon? Of course, there is no any other vertical component because we shall not resolve this in the vertical. So the vertical component is 1,000. Automatically, I will just subtract in the vertical. So the vertical component is 1,000 newtons. A child drinks a liquid of density rho through a vertical straw. Atmospheric pressure is P0, and the child is capable of lowering the pressure at the top of the straw by 10%. The acceleration of free fall is G. What is the maximum length of straw that will enable the child to drink the liquid? Okay, this is very easy. So we know that pressure is equal to H density times G. So the pressure here, because the child can lower the pressure at the top by 10% of that of the atmospheric, so this is going to be 10% or 10 over 100 times P naught, which is going to be equal to H, which is going to be equal to H times the density, which is given as rho, times G. So it means H is going to be equal to 10%. So this is going to be, I'm making H the subject, so 1 0 cancels out. So I have P naught divided by 10 times density times G. So P naught divided by 10 times density times G. So this means my answer is going to be A. A submarine descends vertically at constant velocity. The 3 forces acting on the submarine are viscous, drag, upthrust, and weight. It is descending. A submarine descends vertically. So upthrust is constant, the weight is constant. Because it is descending, of course, the viscous drag, because it is descending at constant velocity, it means the viscous drag is constant. The drag is also constant. So it is descending. So if it is descending, weight is going to be equal to upthrust plus the viscous drag. The upthrust is constant, the weight is constant, the viscous drag is constant. So weight is equal to upthrust plus the viscous drag. Since it is constant velocity, acceleration is equal to 0, resultant force is 0, so the forces must be balancing. So weight is less than the drag, that is not true. Weight is less than upthrust, that's not true. Weight is greater than the upthrust, of course that is true. Weight is equal to the drag. This is not true because there is upthrust. So it means the answer is going to be D. Weight is greater than the upthrust because weight is the upthrust plus the drag. So the answer is D. A cylindrical block of wood has a cross-section area A and weight W. It is totally immersed in water, totally immersed. So the upthrust is constant with its vertical axis. The block experiences pressures PT and PB at its top and bottom surface area, respectively. Which of the following expression is equal to the upthrust? So the upthrust is cross-sectional area times difference in pressure. Remember, the pressure at the bottom is greater than the pressure at the top, because pressure increases with the depth. So this will be pressure at the bottom minus pressure at the top. So the answer is going to be pressure at the bottom minus pressure at the top times A. The answer is going to be C. A mass of a liquid of density ρ is thoroughly mixed with an equal mass of another liquid of density twice ρ. So we have density ρ and twice ρ. No change of the total volume occurs. No change of the total volume occurs. Okay. What is the density of the liquid mixture? That is very beautiful. To start with, we know that density is mass divided by volume, or volume is mass divided by density. So I'm going to come up with probably two equations. So number one has, let the first one have, okay, let this be for the first one whose density is ρ. Volume is mass over density. For the second one, whose density is twice ρ, then we shall have that twice of density, twice ρ is going to be the mass. The mass of a liquid of density ρ is thoroughly mixed with an equal mass. They have the same mass. So the other one will also be m divided by the volume. I'll call its volume V2. And what does this imply? This is going to imply that V2 is going to be mass divided by twice ρ. So I have those two equations now. I have one which is V is equal to mass over ρ, and I have another one which is V2 is equal to mass over twice ρ. So the question is, what is the density of the liquid mixture? Remember, we say the density of a mixture is total mass. Total mass is going to be m plus m, so which is twice m divided by total volume. Total volume is going to be V plus, oh, when you look at these two, you notice that V2 is half of V, because this is m over ρ, this is m over 2 ρ, so V2 is a half of V. So total volume is going to be V plus V2, which is a half of V. That is total volume. So we can simplify this. So this will be 2m divided by 3v over 2. So this becomes, the 2 goes up, it becomes 4m divided by 3, 4m divided by 3v. Remember, mass over volume was density, so this becomes 4 over 3 times ρ. So 4 over 3 times ρ, so the answer is going to be A. An object immersed in a liquid in a tank experiences upthrust. What is the physical reason for upthrust? Upthrust is due to the difference in pressure on the top and the bottom of the object, and we know that pressure increases with the depth. So the answer is C. The pressure in the liquid increases with depth, because pressure is equal to density times G times the depth. Rho and G are constants. H is the one which increases as the object sinks, so pressure increases with depth. So the answer is C. A uniform beam of weight 50 newtons is 3 meters long and suspended at a pivot situated 1 meter from one end. When a load of weight W is hung from that end, the beam is in equilibrium, as shown in the diagram. What is the value of W? So it is a uniform beam. Therefore, its weight acts at its midpoint, and this weight is 50 newtons. The beam is 3 meters, so from this point to the other point is 1.5, from this to the other end is 1.5, so this distance here is automatically 0.5. So taking moments above the pivot, this is clockwise, this is anti-clockwise. So W times the perpendicular distance, which is 1.0, is equal to 50 times the perpendicular distance, which is 0.5. Without even pressing the calculator, W is going to be 25 newtons. So the answer is A. The diagram shows a sign of weight 20 newtons suspended from a pole attached to a wall. The pole is kept in equilibrium by a wire attached at point X of the pole. The force exerted by the pole at point X is F, and the tension in the wire is 40 newtons, which diagram represents the three forces acting at point X. So the weight is vertically downwards. The normal reaction must be to the right hand side. The tension must be in that direction. Remember, these are acting at the same point. They should form a closed triangle. They're acting through the same point. They should form a closed triangle for equilibrium. Let's begin by checking closed triangles. So this one, if I move like this one is the other way around, so this is not closed. This one, if I move like, of course, this is not closed. This is not a closed triangle because this is automatically not closed. This points this side, this point the other side, that is not closed. Then D is not closed. There's no way I can form a closed triangle. There's no way I can move in one direction for D. Let's check B. The weight downwards, the force from the wall to the right, the tension in that direction, and this is forming a closed triangle, which is anti-clockwise. So the answer is going to be B. Two solid substances P and Q have atoms of mass MP and MQ respectively. They have NP and NQ atoms per unit volume. I think we have answered such a question, but we shall still answer it. It is found that by the experiment that the density of P is greater than the density of Q. So rho of P is greater than rho of Q. Which of the following deductions from this experiment must be correct? So we note that the number of atoms, let the number of atoms over volume be simply n. That means the volume is simply going to be the number of atoms. The volume will be the number of atoms divided by n. So since it is per unit volume, so it means V will simply be 1 over n. So let's now start. So density of P will be the mass of P over the volume of P. Remember, density is mass over volume. So the volume of P will simply be 1 over n of P. And then for Q, the density of Q will be equal to the mass of Q. And the volume of Q will be 1 over n of Q. So you notice that when I simplify this, the density of P is going to be M P N P, and the density of Q is going to be M Q. The NQ goes up, so it is times NQ. But they said the density of P is greater than the density of Q, so the answer is going to be C. MPNP is greater than MQNQ, so the answer is C. What is the center of gravity of an object? Center of gravity is the point on an object. It may not actually be on an object. The point where the entire mass, the entire weight of the object may be considered to act. That is the center of gravity. So the answer is C. The hydrostatic pressure P at a depth h in a liquid of density rho is given by the formula pressure is equal to h rho g. Which equation or principle of physics is used in the derivation of this formula? Pressure is force over area. Force will be the weight over area. The weight will be mg over area. Mass is density times volume. So this will be times g over area. So we are using density times volume, or mass is density times volume. So density is mass divided by volume. So we have used this one. We have not used this one. Because the volume, this will be density. Volume is cross-sectional area times a height, then times g over area, then the area cancels out, and you remain with the density g and h. So we haven't used this one. We have not used this one. So we have used this one here. So the answer is A. The diagram shows three forces acting on a body. In which diagram is the body in equilibrium? It should be a closed triangle. For equilibrium, look at a closed triangle. So if I try to move like this, notice that this one is the other way around, so this is not closed. If I try to move like this one is the other way around, so this is not closed. If you try to move, there is no way you can move in you can follow a closed triangle here, because if you try to move anti-clockwise, the other one is the other way around, so this is out. Automatically the answer will be D. We can see if we can move around in a continuous loop with D. So if I move like this, I can come back to the same point. It is a closed triangle, so the answer is D. A force F is applied to a beam at a distance D from a pivot. The force acts at an angle theta to a line perpendicular to the beam. Which combination will cause the largest turning effect about the pivot? So this one is acting like this. So if I resolve this vertically upwards, it will be F cos theta. And I think when the force is acting perpendicular, then the perpendicular distance will be D, will be actually maximum D. Then when it is acting like this, because we shall have to look for the perpendicular distance from the pivot, which will be relatively smaller. And remember the torque, the turning effect, or the turning effect, which is the torque, is going to be F cos theta times the perpendicular distance D. So which combination will cause the largest turning effect about the pivot? So number one, F is large, okay, and D is large, okay, and theta is large. Of course, when theta is large, for theta, if theta increases, cos theta decreases. So this means the torque will be, therefore large value of theta decreases the torque. So this one may not form the largest turning effect. Let's check another one. Suppose F is large, cos theta times D. So F is large, okay, D is large, that is fine, and theta is small. So if theta is small, then it means cos theta is going to be large. Therefore, the torque is going to be large. We shall have large, large, large. If theta is small, cos theta is large. So it means the torque is going to be largest. So the answer is going to be automatically going to be B. Of course, if F is small, D is small, and theta is large, automatically torque is small, because cos theta becomes small when theta is large. F small, theta small. As long as F is small, then it is going to be less than the values in B. So the answer is automatically going to be B. I just used inspection and simple trigonometric ideas. A rigid uniform bar of length 2.4 meters is pivoted horizontally at its midpoint. Weights are hung from 2 points of the bar as shown in the diagram. To maintain horizontal equilibrium, a couple is applied to the bar. What is the torque and direction of this couple? Okay, so we first find the direction of the resultant. Then to balance this, we shall need the opposite direction. So let's check. Clockwise moments. For the clockwise moments, we have 300 newtons times the perpendicular distance. It was pivoted at the midpoint and it was 2.4 meters. So this distance from here to the extreme end is 1.2. So 1.2 minus 0.4, this distance here is going to be 0.4. 1.2 minus 0.8, that is 0.4 meters. So this will be times 0.4 meters, which I think is 300 times 0.4, that is 120 Newton meters. That is clockwise. For anti-clockwise, we have anti-clockwise moment, we have 200 times the perpendicular distance, which is 0.8. So 200 times 0.8, that is 160 Newton meters. So the resultant is equal to 160 minus 120, which is 40 Newton meters, and the resultant is anti-clockwise. To maintain horizontal equilibrium, a couple must be opposite to this. So the required couple should be opposite to the resultant. So the needed couple should be 40 Newton meters clockwise. So the answer is automatically going to be A. An object has an initial velocity u. It is subject to a constant force F for time for t seconds, causing a constant acceleration A. The force is not in the same direction as the initial velocity. The force is not in the same direction as the initial velocity. A vector diagram is drawn to find the final velocity v. Okay, so v is the final velocity. What is the length of side x? What is the length of side x of the vector diagram? So an object initial velocity u, it is subject to a constant force F for t seconds, causing a constant acceleration. Okay, if the acceleration is constant, so I can say v is equal to u plus at. That is the first equation of motion. So v is u plus at. V is the resultant velocity is equal to the initial velocity plus at. So automatically side x is going to be a times t. So the answer is C. What is meant by the weight of an object? What is meant by the weight of an object? So of course weight is the force of gravity. That one is going to waste a lot of time. The gravitational field, the gravitational force. So the answer is B. Weight is the gravitational force acting on an object. Two 80 Newton forces act at each end of the beam of length 0.6 meters. The forces are parallel and act in opposite directions. The angle between the forces and the beam is 60 degrees. What is the torque of the couple exerted on the beam? What is the torque of the couple? Remember, torque of the couple is the product of one of the forces and the perpendicular distance between the two forces. So to easily find the perpendicular distance between these two forces, remember the forces must be making 90 degrees with the line joining them. So I'm going to easily resolve this perpendicularly, and I also resolve this perpendicularly. So if I draw a horizontal line here, I think this angle here is 60. So using 60 to resolve perpendicular, this is going to be 8 sine of 60. Using this angle here is going to be 60 degrees. Using that angle to resolve perpendicular, still this will be 8 sine of 60. So now I know the couple is 8 sine 60 in magnitude. The forces are that. So the moment of the couple, or the torque of the couple, is product of one of the forces, which is 8 sine 60, times the perpendicular distance between them, which is going to be 0.60. So we press our calculator. 8 sine of 60 times 0.6, which is 4.16 or 4.2. So the answer here is going to be 4.2 Newton meters. Of course, this cupola is this torque. The torque of this cupola is actually anti-clockwise. So the answer is B. So you couldn't just use 8 times 0.6, not at all, because they were not perpendicular. The length 0.6 is not making 90 degrees with these forces. I had to resolve them so that I take 0.6 as a perpendicular length to these forces. The density of mercury is 13.6 times 10 power 3 kilograms per meters cubed. The pressure difference between the bottom and the top of a column of mercury is 100 kilopascals. What is the height of the column? So pressure is force over area, which is density times G times H. So it means H is going to be the pressure, which is 100,000 divided by G, which is 9.81 times the density, which is 13.6 times 10 power 3. So we have 100,000 divided by open brackets 9.81 times 13.6 exponent 3. So that is 0.75. So H is 0.75 meters. So the answer is A. The ball is falling at terminal speed in still air. The forces acting on the ball are upthrust, viscous, drag, and weight. Of course, the weight will be constant. The upthrust will also be constant if it is already in air. What is the order of increasing magnitude of these forces? Since it is falling, it is only because the weight was actually greater. But the weight is equal to upthrust plus the viscous drag. So the weight is the biggest. The weight is going to be the biggest because the weight is downwards and the upthrust is upwards. The viscous drag is upwards. So the weight is upthrust plus V. So the weight must be the biggest. So it means we ignore C and D. Then between the upthrust and the viscous drag, which one is greater? Let's check. A ball is falling at terminal speed in still air. Since it is still air, it means the viscous drag is very small. For still air, V is very small. But remember, upthrust depends on the difference in pressure on the top and the bottom. So, and this will depend on the height or on the dimensions of the object. So it means the smallest is going to be the viscous drag, followed by the upthrust. The weight will be the greatest. So the answer is going to be B. Because it's still air, the the viscous drag is small. Two rigid rods XY, YZ are fixed to a vertical wall at points X and Y. A load of weight W is hung from point Z. The load is not moving. Okay, the load is not moving, so it is in equilibrium. So let's see the forces acting here. We have this tension here. So the weight is vertically downwards. So this is pulling, it's like this is pushing this one. So the tension here is going to be in this direction here. And this is like pulling this one away from the wall. So this is going to be in that direction there. Okay. So it means when I form a vector triangle, most likely I will have the weight vertically downwards. Then I will have this one here. And then I will have this one here. So let's see which diagram shows the forces acting at point Z. Remember, they should form a closed triangle. We can start by inspecting the closed triangles. If I move like this is already not a closed triangle. If I check C moving like this, the other one is the other way around. This is not a closed triangle. I can check D. D is a closed D is not a closed triangle because if I move like this one is the other way around, so this is not a closed triangle. Automatically, it means the answer is going to be A. Let's check if it is a closed triangle. Moving like this, we can come back to that position, so it is a closed loop. So that is equilibrium. Remember, for equilibrium, we must have a closed triangle. For equilibrium, we have a closed triangle. The formula for hydrostatic pressure is that. Which equation or principle of physics is used in the derivation of this formula? We have already answered. This is A. If you want me to remind you, pressure is force over area. Pressure is weight over area. The weight will be mg over the area. The mass is density times volume times g over the area. This will be density, volume is cross-sectional area times another height, then times g over the area, and a cancels out. We have not used mgh. We have not used the concept of pressure decreasing with height. We have not used decrease density, increase with depth. So the answer is A. The diagram represents a sphere underwater. P, Q, R, and S are forces acting on the sphere due to the pressure of the water. Okay. So if it is due to the pressure of the water, so it means the pressure at S is the same as the pressure at Q. And since pressure increases with the depth, it means the pressure at R is greater than pressure at P. So even the forces at R is greater than forces at P because pressure increases with depth. Pressure equals to density times G times H. And you notice that R is at a bigger depth than P, so the R is greater than P. Let's check the question. Each force acts perpendicular to the surface sphere. P and R act in opposite directions vertically. Q and S act in opposite directions horizontally. Which information about the magnitudes of the forces is correct? So we have said S is equal to Q, and that is the same for all of them. But we also said R is greater than P or P is less than R. So let's check. P should be less than R. The answer is going to be A because pressure increases with depth. R is at a greater depth, so the pressure there is greater. So even the force there is greater because force is equal to pressure times area. So if the pressure is greater, it means the force is also greater at R. An object made from two equal masses joined by a light rod falls with uniform speed through air. Which statement about the equilibrium of the system is correct? The rod remains horizontal. So which statement about the equilibrium of the system is correct? Okay. It is falling in air with a uniform speed. So it is not in equilibrium because it is falling steadily. That is not true. It is not in equilibrium because it is in motion. It is actually in equilibrium. It is not in equilibrium because there is a resultant torque. It is actually in equilibrium. It is in equilibrium because there is no resultant force and no resultant torque. So the answer is D. The rod remains horizontal. It is made from two equal masses joined by a light rod. It falls with uniform speed, no resultant force. The rod remains horizontal. It means there is no resultant torque. It is not rotating. So the answer is D. It is in equilibrium because there is no resultant force and no resultant torque. The spindle is attached at one end to the center of a lever 1.20 meters long and at its other end to the center of the disc of radius 0.20 meters. A cord is wrapped round disc passes over a pulley and is attached to a 900 Newton weight. Okay, I think we answered this question. We shall just answer it directly. What is the minimum force F applied to each end of the lever that could lift the weight? Okay, so there's tension in this line, this cord here, which tension is still 900 newtons because it is pulled, the weight here is 900. So the perpendicular distance from that length to that point there is the same as this one. And notice that this is actually anti-clockwise moment, and yet the torques are causing a clockwise moment. So for equilibrium, they should be equal. So the force F times the perpendicular distance. The perpendicular distance is actually 1 point. Okay, the torque due to the due to the couple is F times perpendicular distance, which is 1.2. That torque is clockwise, should be called the anti-clockwise torque, which is 900 newtons times the perpendicular distance, which is 0.2. So what is F? So we have 900 times 1.2 divided by, sorry, it is 900 times 0.2 divided by 1.2. That is 150 newtons. So this is 150 newtons. So the answer is going to be B. The forward motion of a motorboat is opposed by forces F, which vary with the boat's speed V in accordance with the relation V, F is equal to kV squared, where K is a constant. The effective power of the propeller required to maintain the speed is V. The speed V is P, which expression relates K, P, and V. Okay, first of all, we know that power is equal to force times velocity. Power is force times velocity, so power will be equal to, where there is force, I'll put K times V squared, again times V. So it means power is equal to KV cubed. So which means K is going to be power divided by V cubed. So it means the answer is going to be C. K is P over V cubed. The diagram shows a flask connected to a U-tube containing liquid. The flask contains air at atmospheric pressure. So the pressure here is atmospheric, so that's why even the liquids are at same height. The flask is now gradually heated and the liquid level in the right-hand side of the U-tube raises through a distance h. So if this raises through a distance h, it means this side it falls through a distance h. So the total distance, this one falls a distance h, the other one raises a distance h. So the total difference in the height, total change in the height is going to be twice h. Okay, what is the increase in pressure? So pressure is simply going to be density times g. The total change in height is going to be twice h. Total change in height is going to be twice h, so the answer is automatically going to be D. As the liquid on the left hand side falls by h, the other one rises by h, so the total difference in height is going to be twice h, as simple as that. A pendulum bob is held stationary by a horizontal force H. The three forces acting on the bob are shown in the diagram. Okay. The tension in the string of the pendulum is T. The weight of the pendulum is W. Which statement is correct? Okay. First of all, let's try to resolve this vertically upwards. Using this angle, this will be 30 degrees. Taking T to the vertical, that will be T cos of 30. For equilibrium, of course, we know that T cos of 30 should be equal to W. T cos 30 equals to W. T cos 30 equals to W. I see that equation here. So the answer is C. Which statement is correct? So this one is correct. Of course, in the horizontal, we should have that T sine of 30 should be equal to H. T sine 30 equals to H. T sine 30 equals to H. T sine 30 equals to H. We don't have that. So the answer is C. What is meant by weight of an object? That is the gravitational force acting on an object. So the answer is B. At a depth of 20 centimeters in a liquid, density is 1,800 kilograms per meter cube. The pressure due to the liquid is 0. Another liquid has density 1,200 kilograms per meter cubed. What is the pressure due to this liquid at a depth of 60 centimeters? Okay, so for the first liquid, we see that, let's say the pressure is P. P is going to be depth, of course, pressure is H, density times G. I will not change the H from the units of H. So P is going to be H, which is 20 centimeters, times the density, which is 1,800, times G. I will not even substitute G. Then for the second liquid, the pressure P2 is going to be at the depth is 60 centimeters. The density is 1,200, then times G. So at a depth of 20 centimeters in a liquid of density rho, the pressure due to the liquid is P. Another liquid has a density of 1,200 kilograms. What is the pressure due to this liquid at a depth of 60? So I'm just going to divide these two. So P2 divided by P is going to be equal to G cancels, centimeters cancels, so I will remain with 60 times 1,200 divided by 20 times 1,800. So when I press, I think this divides out, and I think this is going to be, I think this is 2. So this gives us 2. Yeah, this is 2. So it means P2 is equal twice P. So the answer is automatically C. The pressure at that point is going to be twice the other one. As simple as that. A force F is applied to a freely moving object at one instant of time. The object has velocity v and acceleration a. Which quantities must be in the same direction? Of course, F and A must be in the same direction. The body accelerates in the direction of the resultant force, because acceleration and the acceleration, okay, all these are vectors. So the body speeds up, or its velocity changes in the direction of the resultant force, and its acceleration is in the direction of the resultant force. So all the vectors will point in the same direction. So which quantities must be in the same direction? A force F is applied to a freely moving object. At one instant of time, the object has velocity v. Okay, it could be changing direction, and acceleration a. Which quantities must be in the same direction? So the answer is going to be automatically B. The force and acceleration are always in the same direction. From F is equal to ma. F and A are always in the same direction. The body accelerates in the same direction as the resultant force. The graph shows how the pressure exerted by a liquid varies with depth below the surface. So we have pressure against depth. What is the density of the liquid? Of course, we know that pressure is H, density times G. And we know that the gradient, if it's a graph of pressure against depth, so the gradient of this graph is going to be density times G. So it means density times G is going to be equal to the gradient, which is, let's just say 3000 minus 0 divided by 0.4 minus 0. So it means the density is going to be equal to 3000 divided by 0.4 times 9.81, which gives us 3000 divided by 0.4 times 9.81, So that is 760, approximately 760. So the answer is going to be B. Which two vector diagrams represent forces in equilibrium? Remember, for equilibrium, it must be a closed triangle. It must be a closed triangle for equilibrium. So you can try to move around. If you try to move around, these are forming that loop. This is the other way around, that's not closed. You try to move around, this one is forming this loop. This one's the other way around, that is not correct. It's not equilibrium. If I try to move around R, this one takes me back to the same position. It is a continuous loop, so that is equilibrium. If I try to move around S, this one forms a closed loop, continuous closed loop, so that is equilibrium. So we have R and S, so the answer is automatically C. A long uniform beam is pivoted at one end. A force 300 newtons is applied to hold the beam horizontally. It is uniform. Its weight is at the center. What is the weight of the beam? So let's look for the center. Let's say the center is approximately here. So this is the weight of the beam W. Now the beam is 2.5 meters long. So 2.5 divided by 2, that is 1.5. So this distance is 1.25 meters. Even the other one is going to be 1.25 meters. So a force of 300 newtons is applied to hold the beam horizontally. So the weight is going to cause a clockwise moment, and this force is going to cause an anti-clockwise moment. So the weight W times the perpendicular distance, which is 1.5, should be equal, 1.25 should be equal to the force of 300 newtons times its perpendicular distance, which is the perpendicular distance is 2.5 minus 0.5, which is this distance here is just 2 meters. So that is times 2. So what is W? So we have 600 divided by 1.25, which is 480. So W is 480 newtons. So the answer is going to be B. A uniform beam of weight 100 newtons pivoted at P as shown. Weights 10 newtons and 20 newtons are attached to its ends. The length of the beam is marked off at 0.1 meter interval. So each is 0.1. At which point should a further weight of 20 newtons be attached to achieve equilibrium? Okay, so it is a uniform beam of weight 100 newtons, so its weight is at the midpoint, and I think this is the midpoint. So here we have 100 newtons. So this is causing anti-clockwise moment, this is causing anti-clockwise moment. It means the clockwise moment is now smaller because we have this distance is 0.1, and I think 100 times 0.1 is 10. Then 10 times 0.6 is 6, so that is 16. And on the left hand side we have 20 times 0.4, which is 8. So the other one should be the other side. I'll call the distance x. I'll call the distance x, where another 220 Newton force is applied on the right hand side. So taking moments about the pivot, we shall have that 20 times x plus 20 times 0.4 should be equal to 100 times perpendicular distance 0.1 plus 10 times 0.6. So that is 20x, that is 8. So we have 20x plus 8 is equal to 16. So 20x is equal to 8. And x equals to, I think 8 divided by 20 is 0.4. So x is 0.4 meters. So you notice that the 20 Newton is placed at exactly D. So the answer is D. Because it should be 0.4 from from the pivot, so it is at D. A car with a total mass of 1,400 kilograms is traveling at a speed of 30 meters per second. What is the kinetic energy? So this is not supposed to be here, but we shall answer it. Kinetic energy is a half mv squared, so that is a half times the mass 1,400 times v, which is 30 squared. So a half is 0.5 times 1,400 times 30 squared. So that is 630 kilojoules, or 630,000 joules. So the answer is C. Why does the pressure increase when a sealed container of gas is heated? Sealed is heated. Of course, here the molecules gain more kinetic energy and they move faster. So let's see. The gas molecules collide more often with each other. Because it is heated, then we cannot talk about colliding more often. The gas molecules expand. That is not possible. The gas molecules travel faster and hit the walls of the container more often. They travel faster because they have gained more kinetic energy, and they hit the walls of the container more often. So the answer is going to be C. Liquids X and Y are stored in large open tanks. Liquid X and Y have densities 800 kilograms and 1,200 kilograms respectively. At what depths are the pressures equal? So we want a depth where pressure due to X is the same as pressure due to Y. Remember, pressure is H density times G. So H for X, density for X, G is the same. H should be equal to H for Y. Density for Y, G is the same, so G cancels out. So at what depth? So I have Hx divided by Hy should be equal to density of Y divided by density of X. This is going to be equal to 1,200 for Y divided by 800 for X. So it means Hx over Hy is equal to 1.5. Okay, so we can check. Hx divided by Hy gives you 1.5. We can start with 8 divided by 12. That is not correct. 10 divided by 10, that is 1. 15 divided by 10, that is 1.5. 18 divided by 8. 18 divided by 8, that's not 1.5. So the answer is going to be C, because Hx over Hy should be 1.5. So the answer is C. Which force is caused by the pressure difference? That is upthrust. We said upthrust is cross-sectional area times difference in pressure. Three coplanar forces, each of magnitude 10 newtons, act through the same point of a body in the directions shown. What is the magnitude of the resultant force? Magnitude of the resultant force. Okay. So we are going to resolve in the vertical. Resolving the two forces in the vertical, since they are equal in magnitude and the angle is the same, I would simply say they form twice. 2 times 10 cos of 30. It's the same as saying 10 cos 30 plus 10 cos 30. That is 2 times 10 cos 30. The vertical minus 10 newtons. So let's check that. 2, this is F in the vertical, quote Fy. So 2 cos of 30 minus 10. So the resultant is downwards. So this is equal to 7. Is it 7? No. 2 cos 30. 2 cos 30. There is a 10 somewhere. Minus 10. So this is 7.32. Of course, the negative is showing that this is going to be downwards. So the answer is automatically C without wasting time. What is the magnitude of the resultant force? It is 7.3 because this in the horizontal point to this side, T sine of 30, and the other one will also be T sine of 30. So there is no resultant in the horizontal. Which statement defines the density of a substance? Density of a substance, density is mass divided by volume. So mass per unit volume. So the answer is automatically C. The table summarizes some properties of evaporation. Of course, evaporation is no longer in this unit, this topic, or is no longer in AS. Which row of the table is correct? Involves a change in state from liquid to vapor. Of course, evaporation involves a change of state, so the false part is out, D is out. Occurs at a fixed temperature. Evaporation can occur at any temperature, so it means the true part is out, so we have eliminated A. Evaporation occurs at any temperature. Whether heating or not, there is evaporation. So we remain with the B and C. Involves a reduction in the average kinetic energy. Of course, when evaporation occurs, the more energetic molecules will escape, leaving behind the less energetic molecules. So the average kinetic energy remaining in the liquid is smaller. That's why the temperature reduces. So it involves a reduction in the average kinetic energy of the remaining atoms. So the answer is B, because this is true. This is false. This is true. So the answer is B. The symbol G represents the acceleration of free fall. Which of these statements is correct? G is gravity. That is not true. We normally say G is gravity, but that is wrong because G is the force due to gravity per unit mass. G is reduced by air resistance. G is constant. G is the ratio of weight over mass. This is very true. The gravitational force per unit mass, that is G. G is the weight of the object. That is not true. The diagram shows a plan view of a door which requires a moment of 12 Newton meter to open it. Okay, it requires a moment of 12 Newton meter to open it. What is the minimum force that must be applied at the door's midpoint to ensure it opens? So at the midpoint, we want to put a force at the midpoint and it should cause the same moment. So that means if we put here the force, the perpendicular distance from the turning point is 0.4. So F times 0.4 should give us 12 Newton meters. So it means we shall simply say that 12 divided by 0.4, that is 30 newtons. So F is 30 newtons. This means our answer is going to be D. You notice that the questions here are now very simple because these were early years, 2001, 2002. These were early years, but as Cambridge advances, the questions become more technical. So two solid substances P and Q have atoms MP and Q respectively. Those are the masses. There are NP and NQ atoms per unit volume respectively. It is found by experiment that the density of P is greater than the density of Q. We have answered this the second time. This is the third time. Density of P is greater than density of Q. Which deduction from this experiment must be correct? Okay. So for the density of P should be greater than density of Q. Density is mass over volume. So the mass over volume for P should be greater than the mass over volume for Q. So let's substitute. The mass for P is MP, and the volume, since they gave us the number of atoms per unit volume, so here 1 over V is the same as NP. So this should be greater than MQ, and 1 over V will be NQ. So the answer is automatically C. A submarine carries a pressure A submarine carries a pressure meter so that the crew can work out how far they are below the surface of the sea. At the surface, the meter indicates a pressure of 100 kilopascals. The density of seawater is 1030 kilograms. What is the depth below the surface when the meter reads 450 kilopascals? Okay, so we want simply the depth. We want the depth. So I would simply say that the difference in pressure is going to be equal to difference in the depth times density times G. So the difference in pressure is going to be 450 minus 100. Of course, this is kilo, so I'll say times 10 power 3 should be equal to the difference in depth times the density, which is 1030, times G, which is 9.81. So we have 450 minus 100, I think that is 350. 350 exponent 3. Then I divide this by 1030 times 9.81. So I'm getting the difference in height is a problem with this pen now. So the difference in height is actually about 34.6 meters. So the answer is going to be A. What is the center of gravity of an object? What is the center of gravity of an object? So this is the point where the entire weight is considered to act. So the answer is C. The point at which the weight of the object may be considered to act. And the last page for this, the diagram shows two pulley wheels connected by a belt. Wheel Q is driven by a motor and rotates clockwise. So wheel Q rotates clockwise, so this is pointing that direction. This must be pointing that direction if it rotates clockwise. Wheel Q puts tension in the top portion of the belt, which in turn drives the wheel P. The lower portion of the belt is slack and has no tension. So the lower belt is slack and has no tension. The weight of the belt and frictional forces are negligible. The diameter of P is 150 millimeters and the diameter of Q is 100 millimeters. The torque applied to Q is 3 Newton meters. What is the tension in the belt and the torque on wheel P? Okay, so the torque, remember torque is going to be the product of the force and the perpendicular distance. So to begin with, the torque here, the torque applied to Q is 3 newtons, so we shall say 3 newtons is equal to the tension in the top times the perpendicular distance, because they said because the rotation is about the center and this wheel has a diameter of 100 meters, so this is going to be 0.1 in meters. Then we divide by 2 to get the radius, so this is going to be times perpendicular distance 0.1 divided by 2 is rotating about the center. So this means the tension here is going to be, I think this is 6 over 0.1, which is going to be 16 newtons. So the tension in the top must be 60 newtons. So tension in the top of the belt is 60. So this is out, this is out. So without even checking the second one, the answer is going to be D. You can check the torque on wheel P. You can check the torque on wheel P. If the tension is 60 newtons, what is the torque on wheel P? You can check by also considering the diameter of wheel P, which is where you get the radius by dividing it by 2. That is, the torque on wheel P is going to be, the tension of course is going to be the same because they are connected on the top. The tension here is the same, so it is going to be 60 newtons times perpendicular distance from the rotating point. It is 150 divided by 2, which is 150 over 100 is 1.5, then divide by 2 to get the radius. and this gives you, I think, 4.5 Newton meters. So automatically the answer is D. A rectangular metal bar exerts a pressure of 15,200 pascals on the horizontal surface on which it rests. If the height of the metal bar is 80 centimeters, what is the density of the metal? So density is going to, okay, pressure is density times G times H. So the pressure is 15,200. This will be the density. G is 9.81 times the height, which is going to be 80 centimeters. So that is 80 times 10 power minus 2. So we have 15,200 divided by 9.81 times 80 exponent minus 2. So that is density is going to be 1936 or 1937. Density is going to be 1937. These are given two significant figures, so it is 1900. So the answer is B. 1900. Last but not least, three coplanar forces act on an object in the directions shown. In which diagram could the object be in equilibrium? So we can check if when we combine, if we prolong these vectors, they meet at the same point, then that means there is a possibility of them forming a closed triangle. So if I prolong this one downwards, and I prolong this one, I prolong this one, there's no way of these vectors meeting at the same point, so they can't form a closed triangle. Let's check these three. If I prolong this one and prolong this one, there's no possibility of these ones meeting at the same point, so they cannot easily form a closed triangle if we draw them to scale. If we prolong this one and prolong the vertical one and prolong this one, so this one can meet at the same point. That means it is easy to draw them, to combine them head to tail and form a closed triangle of equilibrium. So the answer is automatically C. The answer is automatically C. You can check the last one. So those ones cannot easily form a closed triangle, so this is also out. So the answer here is going to be C. Okay, so this marks the end of force, density, and pressure. I'll be recording a few practicals. Next weekend, I'll record a few practicals, and especially number 2. And I'll record number 1 later on. See you in in kinematics and dynamics. Bye bye.